In that, we have done subtraction only when the subtrahend is smaller than the mean. But what if when the subtrahend is greater than the mean? For that case, complement method is used, which is applicable for all the number systems. Now here we will study binary subtraction using complement method. Binary subtraction method is simple when we have to subtract a smaller digit from a bigger one. That means when our minuend is greater and subtrahend is smaller, then the subtraction is easy. But when the bigger digit has to be subtracted from the smaller one, in that the digital hardware finds old borrow concept less efficient and uses complement method. That means that when we have to subtract a bigger number from the smaller one, the previous borrow concept which we are studying from our early classes, so that borrow concept will be less efficient in digital with the digital hardware. So we will use complement method in our digital hardware system. Now what is this complement method? Now complement method is the subtraction using complements. So in case of binary, we have studied two types of complements. One is 1's complement and second one is 2's complement. So here we will perform subtraction using 1's complement method. So there are certain rules which has to be followed in performing the binary subtraction using 1's complement. The rules are first of all you have to convert both the numbers into binary numbers. Second rule is we have to determine the 1's complement of the subtrahend, that means the second number. Now we have to add this 1's complement of subtrahend into the minuend, and that means first number. Now after doing this process, two cases can arise. First case is if the sum contains n around carry, then further add this carry with the sum to get the final answer. If by the addition of this above thing, if we'll get n around carry. Now what is this n around carry? We have to understand this. Now let us suppose we have two 4-bit numbers like this. Now we will add this 4-bit number. So 1 plus 1 is sum bit is 0, carry bit is 1. Now 1 plus 1, sum bit is 0 again, carry bit is 1. Now we have 3 1's consecutively. So we have sum bit is 1 and carry bit is again 1. Again for this, sum bit is 1 and carry bit is again 1. So we are having in answer 5 bits rather than the 4 bits. So this 5th bit which we are getting in our answer is called end around carry. So similarly, when we deal with two 8-bit numbers, if we get in the sum 9th bit, so that is called end around carry. Now that is the first case. Now for the second case, if can arise when we will get no carry. Now in that case, the answer will be minus 1's complement of the result. So we can understand this by performing the following example. Now in this example, we have to subtract first of all x minus y and then y minus x. That means we have given two binary numbers x and y. So we have to perform two subtraction. One is x minus y and second one is y minus x. Now it is obvious that from among x and y, one number is greater and one number is smaller. So that means among these two subtraction 1 and 2, one subtraction answer for one subtraction will be positive and another will be negative. We can't judge that which one is positive, which one is negative, because these are the binary numbers. We can't say which one is greater and which one is the smaller one. So we will do this by performing the following steps. So here first question we will solve by that is x minus y. Now in this case, what we will do, we will take 1's complement of the subtrahend, that is y. So 1's complement of y is, you can see from here, 1's complement of this number is 1 changes to 0, then 4 times 0 will be 4 times 1, then 0 0. Now add these two numbers. By adding these two numbers, we get this sum, and this 8th bit. These are the two 7-bit numbers, so we are getting 8-bit extra bit. That is called end around carry. Now this end around carry is summed up into the previous answer. So finally we will get this answer. Now this, what is this? This is simply a 17 answer. If we will calculate its decimal equivalent, it is nothing but a 17. So we can say that x is greater than y because we are getting the sum positive. So now we will perform the second subtraction, that is y minus x using 1's complement. So in that we have to, in this subtrahend is x, so we have to take 1's complement of this number. So 1's complement of this number is written here 0, 1, 0, 1, 0, 1. Now here the second case will arise. That means in this sum we are not getting any extra carry. That means no carry results. No carry results, then we have to take 1's complement of the sum which we have got in the previous step and with the negative sign. Or you can say this is also your answer, but this answer which we are given here, this answer is in just 1's complement form. So if you will find its equivalent binary, so what will be your answer? Answer will be, your leftmost bit is 1, so this is reserved for negative sign. Now rest of the, we will take 1's complement of rest of the number, it is 1, 0, 1's complement will be, it is not 1, it will be 0, 1, 0, 0, 0 and 1. So this is same as we are getting answer here. So this is nothing but, this can be also your answer, but it is in the 1's complement. So now next we will do the binary subtraction using 2's complement method. So again for 2's complement method, we have to follow certain rules as that in 1's complement. Then first rule is convert numbers into binary, same, determine the 2's complement of subtrahend, and then add the 2's complement of subtrahend to the numerator. Now again two cases will arise. First one is if you get n around carry, then discard that carry. That is the difference. In the previous case, we are adding this carry into our previous result, but in this case we will discard this carry and the rest of the answer is our final answer. Now second case will arise when in the second case when we will get no carry, there will no extra carry. So in that case answer will be minus 2's complement of the result as that of in case of 1's complement. So we will again take the same example so that we can easily verify our answers. So first problem is x minus y. So we have to perform these two subtractions again, but in this case we are doing this by using 2's complement method. So x minus y. Now in this case we have to take 2's complement of this number. Now here is the 2's complement of this number. First bit as it is and rest of the bits are getting inverted. So when we will add these two numbers, we will get this sum. Now as you can say, in adding these two 7-bit numbers, we are getting 8 bit. So that means this is called end around carry. So we have to discard this end around carry in case of 2's complement method. So your answer is simply this one. So you can verify it with the previous answer that it is nothing but representation of 70. Now similarly we will perform y minus x. In y minus x your subtrahend is y, you have to take 2's complement of this number. So this is the 2's complement of the number. So we have to add these two numbers. Now we are on adding these two numbers, there is no extra carry which we are getting. So we can say this is the answer in 2's complement form, or if we want true answer, then we can get it by taking 2's complement of this number which we are getting in previous step and taking negative sign in front of that. So this is our answer. As you can say that this is nothing but 70. Now you can see that this is answer is in 2's complement form. How we can convert it into a decimal equivalent? So as you can say, for the leftmost bit it is just negative sign, and rest of the numbers we have to take 2's complement of this. So 2's complement of this is nothing but right. First one is as it is. Next we have to invert all the numbers. So it is nothing but minus 1, so use 1. So this is nothing but the same answer as that of the this one, minus 7.